The topic is RBAC or role-based access control in Kubernetes. Role-based access control in Kubernetes, or simply role-based access control or RBAC, means that any application, cluster, instance, etc. should not grant admin access to every user. Meaning by default, these services give admin access to every user that is being created. To prevent that, we need role-based access control. It can be in any other platforms or dynamics, that is in instance, AWS, etc. However, with respect to Kubernetes, it is same. We need role-based access control to give certain users certain access that they only need it, not all access, so they can misuse or they can accidentally misuse that to cause damage to the services and the platform. What if we gave admin access to all? If every user in an organization that access cluster or manages it has all the access, meaning quality engineers, developers, DevOps engineers, and if it is a bigger organization, there might be other as well. So if all of these have same access, same control towards the cluster, there would be a lot of mess and it will be difficult to find who made the mistake or who made the blunder. Even if we find out that, it would be late and the damage would be done. To prevent these issues, that is security and deletion of important files or aspects of the cluster, we need role-based access control. Role-based access control is a concept where it grants certain users that only need or have certain responsibilities with respect to the task, and we give them that much access or control towards the cluster. Only admin or administrator will have all the access, and other users, that is developers, quality engineers, DevOps engineers, will have access to the cluster with respect to their responsibilities and how much access they need to fulfill their job and responsibilities. This prevents from security and deletion and management of the production grade environment in an organization. Let's now understand first, that is the identity layer or OAuth, OIDC, IAM. In production, we offload user management. We do not create users inside Kubernetes. The source of truth. We provide AWS, IAM, Okta or Google Workspace via OAuth 2 or OIDC. The login. When a user, for example KEF, authenticates via command line interface CLI, the cloud provider issues a JWT token. The mapping. The Kubernetes API server validates this token. It sees that KEF belongs to the AWS group, that is platform engineers. Kubernetes now recognizes KEF as a valid entry, but he has no permissions yet. So to implement role-based access control in Kubernetes, first we must know there is a concept of user management. It exists in Linux and other as well, but we know simply user management by user add or add user, which means like we do it in the CLI for user add or add user, which grants certain permissions and access to it. However, the best and efficient way to do it is via offloading that headache to other providers. For example, that is OAuth, OIDC or IAM. Meaning, instead of managing or creating every user manually inside the CLI via commands of Linux, we can offload it via these service providers. For example, we would be creating groups and users in these providers. For example, there would be existing groups and users in these providers, that is OIDC, OAuth or IAM, and we would just integrate that through CLI and manage Kubernetes. And you would be using any cloud provider first and then login in via CLI, and then the Kubernetes API validates this token. If it sees that KEF, that is a user that is logging in, belongs to the AWS group platform engineers, Kubernetes now recognizes KEF, that is a user, as a valid entry, but he has no permissions yet. But it is just a step for the login in or user creation or user management. We are offloading it via other providers where this group and this user exists or it is created, and we are just using that information to log in via CLI to manage our Kubernetes. I hope you get the point. Like if there exists a website, we are not always using that website for logging in, meaning there exist certain options in websites, that is Google or other. So we use simply Google, so it is easy for us to log in via it. So it is same as that. Instead of we manually creating users one by one in groups, we offload that user management that gives us clean interface as well with these providers, so we know how much access is required or it is given to the users, that is in the interface format of these providers, as well as we can go into CLI with the login and let users access it with respect to their permissions and role-based access control. But yet they don't have permissions for Kubernetes. It would be given in the next step. Authorization layer in role-based access control. Now that Kubernetes knows who is KEF or user is created, we apply role-based access control. This is a three-tier system. First is the definition, the role. We can think of it as a job description. It is not tied to the person. It defines what can be done. First is role, where permissions for one specific namespace, that is production, payments. Cluster role is to give permissions that work across the whole cluster, for example viewing all nodes. So as the user is created, now we define role-based access control with respect to Kubernetes environment. We know that there exists the concept of namespace and cluster. Cluster is a collection of virtual machines or instances, whereas namespace is an isolated environment across the cluster. So if there exists the namespace production payments, it would be having certain permissions that would be called role. And when an user enters this namespace, it would be having those permissions with respect to it. And if there exist these permissions with respect to the cluster, it would be called cluster role. Now B is the subject or the user or group. This is the identity we got from the step 1. We prefer using groups. For example, system, masters or dev group. So we don't have to update Kubernetes every time a new person is hired. So the subject means we don't use single users to manually give permissions to it. Instead, we create groups that would have certain permissions and we add those users to this group. If this group would be having certain permissions like role-based access control, so members of this group will have access or control with respect to it. And when a new user is added to this group, it would be having those permissions and access control. So we don't have to update Kubernetes every time the new person is hired. Now see the binding, the connection. This is the action of assigning a role to a subject. Role binding, assigning the developer role to the engineering group in the staging namespace. If KEF, the user, is in the engineering group, he automatically inherits those permissions. So all this ABC works together, or they are interconnected, as it is a three-tier system, meaning the subject, the definition, the binding, all this connect together to form this statement. That is, if a user is in the engineering group, he automatically, that is, assign the developer role to the engineering group in the staging namespace. The definition that had cluster role and role, which means these are independent role, that is in namespace, these are independent role-based access control with respect to these namespaces. For example, production payments will have certain permissions in it, whereas in cluster role, it would have certain permissions in it. For example, viewing all nodes. And in second, that is the user or the group, the certain groups will have certain permissions and the user is added to that group, and it is in the binding stage where these two are binded, and it would look like assigning the developer role to the engineering group in the staging namespace. That covers the definition, the subject and the binding. So it would look like if the user KEF is in the engineering group, he would automatically inherit those permissions. Tricky thing here is understanding role and cluster role. We can simply understand them as rules. Instead of role, we can remember them as rules. So in a namespace, there will be certain rules for a certain namespace, meaning it would have certain permissions and access control for that specific namespace. So it would be called role. And if it is with respect to a certain cluster, that means rules with respect to or permissions with respect to that specific cluster, it would be called cluster role. So we would be creating certain role and cluster role with respect to the namespace and the cluster for role-based access control. And users, we know that it is added in a group that has certain permissions, it automatically will have permissions for that user. And in C, we bind those A and B. So it would look like if a user KEF is added in the engineering group, he would automatically inherit those permissions by the help of role binding. Now the service layer, machine to machine. Users aren't the only one who need permissions. Application, that is pods, need them too. This is called service management. Service management SA is an identity created inside a Kubernetes for a pod. The connection. We use a role binding to attach role to the service account just like we did for a human user. Cloud offloading IRSA. If the pod needs to talk to the AWS S3, we annotate the service account with an AWS IAM role ARN. This bridges the KTS internal identity to the AWS external identity. So until now we understood the permissions with respect to the users having access, first access with respect to the cluster and doing actions according to it or in the namespace. Now we get the point that users need permissions, role-based access control, etc. But applications or the pod need them too, which is called service management. By default, there is a service account created inside a Kubernetes for a pod. We would be doing same what we did previously for the user. Now it would be with respect to the application or pod, meaning we will be using role binding concept to attach role to the service account just like we did for the human user. Cloud offloading IRSA. If a pod needs to talk to AWS S3, we annotate or update the service account file or service account with an AWS IAM role ARN, which would bridge the KATS internal identity to the AWS external identity, basically connecting both. So the flow would look like identity, OAuth or IAM. KF, the user logs in, AWS says this is KF, he is the admin, he is the software developer, he is the DevOps engineer. It can be anything. Second would be mapping. EKS maps the AWS admin group to the KATS group. That would be cluster admin, software engineer, DevOps group. Role-based access control. A cluster role binding exists that connects cluster admin, cluster software engineer, whatever group, the built-in cluster admin, software engineer, DevOps engineer in the cluster role. The action would be if the user can now manage the clusters. Service, if the user deploys an app, he creates a service account and a role so the app can read its own configuration, then uses IAM offloading so the app can store logs in the S3 bucket. So this is what the flow would look like. Now summary would be feature for the identity source. For user management, it is external IAM Okta or OAuth. For service management, it is internal KATS service account. Feature auth method for user management humans, it is token or certification via kubectl, whereas for service management or apps, it would be mounted token inside the pod. Feature permission tool for user management humans, it is role-based access control, role or cluster role. For service management, it is same, role-based access control, role or cluster role. Feature cloud integration for user management or humans is EKS access entries or AWS auth, whereas for service management application, that is IAM roles for service accounts, that is IRSA. That is it for the video today. Thanks so much for watching. Have a great day. Bye.